Hey, what's up? What's up? It is Friday. I gotta check to make sure my sound's good. Apparently, it is good. Let's go. Y'all see what the agenda is. So get out yourself a periodic table. Make sure you have one in your agenda. If you don't have one in your home, I might just find one on the internet. It's totally easy. I think there's pttable.com, something like that. That one is actually really good. And then also I have one right here, the periodic table. So that's the kind I've been handing out in class. However, let's get to it. Okay, cool. So if you had to have this as a quiz, could you name all the different things? And again, I could have put up any element. I just put the same one we had yesterday. Could you tell me that this is the element name? Could you tell me this is the, what is it? The atomic number. Cool. So could you tell me those two things? Could you tell me that the atomic number is the number of protons? Could you tell me the atomic number is the number of protons that are in the nucleus, and that the number of protons and the atomic number, they're equal to each other, and that this is how an element is ID'd. It's kind of like a social security number or its driver's license. Could you tell me all those things? If you could, you're good. All right. Could you tell me this is called the symbol? Yeah, the symbol, the shorthand abbreviation. Just as a reminder, they do not always, right, line up between the element name and the symbol. They're not always lined up. Now, could you also tell me this is the atomic, what? Mass. And that's the average mass of the atoms that are in the element. So if you took all of the carbon in the world and you averaged all of their masses together, you would get 12.01. And I think your periodic table probably says 12.011. Okay, so it might say that. And again, it's just saying that if you round it out to the nearest whole number, it would be carbon 12, and that's the most common type. Now, for the ones that are not, we're just going to take a look at this real quick, okay? So we'll just look at these real quick. There's a few that, like, hey, so like if you look right there, there's iron right there, Fe, iron, right? So if you look right there, and again, that one doesn't line up, and it has to do with the names being predating the periodic table. Now, if you come over here, we'll name a few. You got. Oh wait, if I could do this one. All right, sodium right there. That Na is sodium, and then right below that is K. Now, when I was a kid, there was a cereal, and its name was Special K. And guess what it was high in? Hopefully, you got it. Yes, it was high in potassium. I did not know that as a kid, that they were literally using the symbol for the element as the cereal name. I did not know that as a kid. However, now that I'm an adult, I do realize that. Okay, let's keep it pushing. All right, cool. So what is in atom? Again, what is in atom? And I think we actually went through this in yesterday's video. Let me double check so I don't have to redo it all. Okay, we did not. This is one of my favorite parts of the whole school year, to be honest. There's certain activities that I think are really fun. So what is an atom? So what I want you to do is inside your journal, pause the video, and draw an atom. Don't draw just a little tiny speck, okay? You got to draw it big enough for me to be able to see something, okay? So please draw that and do it to the best of your ability. Don't worry if it comes out right. Again, pause the video and do. Yo, did you pause the video? Please let me know if you did. If you didn't, you need to do that right at this moment. Let's go. So most people would draw an element that looks like this, right? Most people would draw an atom that looks like this. So I do want to say a couple of things. Number one, this is halfway right and halfway wrong. So its basics are good, but there's some fundamental flaws. So number one, inside of here, there is a nucleus that's in the center. That's good. Inside of the nucleus is a proton or not a proton, but protons and neutrons. That's also good. Outside the nucleus traveling around are electrons. That's also good. Now, that's exactly where we start to pick up the things that are bad. So if you really wanted to get more precision, you would make the electrons a lot smaller. So maybe the size of that dot right there, that black dot right there, that might be the size of the electron in comparison to the protons and neutrons. It's incredibly smaller than the protons and the neutrons. So just understand that. That also tells us the majority of the mass is inside of the nucleus of the atom. Also, these electrons here, they do not travel on this ellipse because this ellipse makes it feel or think that it just travels around there consistently, but really an electron is more traveling like how the mouse is traveling, like here, 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 here. It's more randomized as to where it is going. We know in general that this is the electron field area that this electron will be traveling in, but we don't always know exactly, we don't know like where is it going to be going. So electrons are more random in their travel. So I just wanted to put that up there. Okay. Let's go ahead and write this down again. I'm just going to walk through this real quick, and then you guys make sure to pause if you need to. So what is an atom? An atom is a very small particle that makes up all matter. We talked about matter yesterday, and we said that matter, right, is anything that has volume or has mass or weight. So atoms make up everything that has a volume and everything that has a mass or weight. And then, this is blah, and they're made up of 3 subatomic parts. Those are protons, neutrons, and those are both inside of the nucleus, and then electrons, and those are traveling around outside in this electron cloud or electron shells, depending on how people call them. So make sure to get that written down. We will talk more about that, so don't trip out, okay? Again, we will talk more about that, so don't trip out. By the way, since atoms, this is the reason they can't be trusted, because they make up everything. There we go. Yeah, did that. All right. So let's go here, and again, pause that if you need it. Again, pause that if you need it. You do not need to draw this part, but again, pause it if you need it. Now, on to the next one. You will need to draw everything. So pause the video here, and then get everything drawn. Now, Mr. Farr is going to go through the explaining, but you should definitely pause the video here, draw everything, then come back and start playing so you can listen, okay? All right, but Mr. Farr is going to keep going at this point. So let me see if I can find, go back. Bop, bop, and then I just need my pen, and I do not want to use that color. I actually want to use blue. Okay, so here we are. So electron they are negatively charged particles, okay? So they're negatively charged, and their charge is a -1, okay? So I just want to make sure that that's cool. They are outside, again, outside of the nucleus. Now, a proton, right, is a positively charged particle, and it has a charge of, hopefully you guessed this, if electron's -1, then a proton is +1. Then a neutron, right, it is a neutral or no charge particle, and it is a +0, okay? So that is how their charges work. Now, how would we go ahead and figure out what is the overall charge of this carbon atom? Well, let's go ahead and count. So this is 1, 2, 3, 4, 5, 6. So it's -6, okay? Then protons were at 1, 2, 3, 4, 5, 6. So that would be +6. And then I'm going to go ahead and move myself up out the way. I'm going to move myself over here. And then let's count these neutrons. So there's 1, 2, 3. There's one tucked way back there. So 4, 5, 6. But because they have no charge, that would be +0. So -6 plus a +6 equals to a 0. And that means that this atom is neutral. Also, something I do want to point out, if you look at the first electron shell that they have here, the first electron shell, it only has 1 and then 2 electrons in it, okay? So I just want to make sure that that is pointed out. So the first electron shell is smaller, and it only can hold 2 electrons. The next preceding electron shells can hold more, and the number that they can hold, and this is called the rule of 8, so a lot of the next preceding ones will hold 8. Now that rule holds up for a large portion of the periodic table. I don't want to go into too many details yet. One step at a time. So hopefully we're good there, okay? Cool. So again, if you need to take notes, finish that, but I am moving forward. Again, I'm moving forward. All right. So we talked about this yesterday, that the periodic table is not a table of molecules or compounds or mixtures. It is a table of elements, right? And it's going to tell you about each element, and if you had one atom of that element, it will give you some information about that one atom of that element, okay? Cool. Also, I'm going to point this out just so that people can see. If you look right here, it says 57, and then it goes over to 72. But if you look down here, here's 58, and there's 71. So they've broken it apart, right? And also, look, here goes 89 to 104. So there's the 90 through 103. And they've broken it apart because if not, the periodic table would be stretching like super long. This way, they've got it onto one page. And then also, this is the other thing. The honesty is the majority of these ones down here are not commonly used, right? So these ones down here are not commonly used. So them being kind of a little bit off to the side is actually okay. They are not the common use ones. It just is what it is. So just realize that it's really for practical purposes as to why the periodic table is kind of broken down this way. Some people asked that. I thought I would just shout that out. Okay, now what I want you to write down is everything. I gotta find my pen. Where my pen is at? Okay, everything on the top right here. So make sure to get all of this down right here. Boom. I'm gonna go ahead and scratch that out, and then I'm gonna take this subscript and I'm gonna say, take that note for right here. I know it's a little bit crazy, so I'm gonna walk through this, and then you can take notes as you see fit. Okay, number one. This whole thing is called the chemical formula, and it is the chemical formula for water. Totally good. Okay, we use this one on purpose because it is a simple one that most people know. Now, this is H2O. This is a subscript. Okay, subscript. So do not write it like this. Do not. It's not that. It should be written this way. H, subscript 2, and then an O. Okay. Now remember, this 2 belongs to whatever element is to its left, and the element to its left is hydrogen. So H2, so there's 2 hydrogens, and then if there's no subscript, that means there is only 1, which means there's only 1 oxygen. So what is the total number of atoms in this chemical formula? Well, there's 2 hydrogens, and there's 1 oxygen. Put them together, you got yourself 3. Okay, so hopefully we saw that. Also, sometimes this is called the chemical symbol, element symbol, so just different things. It can be called different things like that. So just realize that. Pause the screen if you need it, but Mr. Farr is moving forward. Okay, cool. Now, what I want you to do first is over there. This is exactly what we just did on the other page. I just want you to write this down. This is going to be our example for all the ones that we are going to do here, okay? So hydrogen, there's 2 of them, remember? Boom, like this. So there's 2 of those, and that is what checks out right there. Then for the oxygen, there's no subscript, so there's 1 of those. That goes right there, and then the total is 3 atoms. So I just wanted to put all of that there and say that. Now, what you're going to end up doing is you're going to write the chemical formula down for all of these acids. Then the number of each element, just like we did here, hydrogen. So you're going to identify each element and then tell me how many there is of each one. Then what is the total number of atoms in each one of these acids? That's what we're going to finish off. So I'm going to pull this up right here because I think, oh, it went behind me. That's okay. Because I want to do a couple of things. Actually, let me pause right here because I want to pull up something. Okay, so I wanted to say, so the very first one on the list is HCl. However, this is the thing about it. It is HCl, and some people might think that it's hydrogen. They also might, here, let me zoom in. Yeah, that way we can be right upon. Okay, so some people thought that it was hydrogen, carbon, and iodine. Now, this is something I want to show you about the periodic table. But if you take a look at the name, you have hydro, and that is the hydrogen. And then the chloric portion, that is chlorine. Okay, now I want to show you guys something about the periodic table. Let's just go ahead and let me see if I can zoom it in some more. Yeah, there we go. Boom. Okay. Let's just scroll over to where the chlorine. Oh, can we not do that? Oh, that's terrible. Oh no. Okay. So I think I could do that. Nope. Let's see if it'll let me zoom out. There we go. Boom. Let's see if we can zoom in on this part of the periodic table. every time we zoom, it just zooms. Oh, I have to go like this. Ha, I got it now. Okay, so I just wanted to talk about this so you guys could see this. So if you look over here, where every capital letter, right? Every capital letter is the beginning of a brand new element. So if you look, every element starts with a capital letter, capital letter, capital letter. Even the ones that are by themselves, they're all capital letters. So the second letter, if you look, all of them are lowercase letters, okay? So that's telling you this is A, and then that second letter has to be lowercase, so that is a lowercase L. Over here, it is capital S and then a lowercase I. That's how all of them are. That's how we got the hydrochloric acid. So if you look at the chlorine, right, then it is H and then it's Cl. So that is a lowercase L. Now here, this isn't, since this is the first letter, it is an uppercase I, and that is for iodine. So I just wanted to point that out for the folks. Okay. Let's go here, and I'll put myself up there, put that in full. And then, so we'll break this one down real quick for you guys as an example. So this one, there is hydrogen, right? Hydrogen. All right. Cool. And how many is there? There is one. All right. And then what's the next one? Is chlorine. I do not know how to spell chlorine all the way. Let me pause and make sure I get it. It's C-H-L-O-R-N-E. And you know what's crazy? I could have looked right here. I did not have to pause. Oh, well. I still fixed it. So anyway, there's one chlorine, and then atoms in total, there is 2. No problem. Let's just look at this next one so that way we can make sure we're good. All right, so we have hydrogen. This one is a C, and this is a capital O, so that means this is carbon, this is oxygen. So we're going to say hydrogen, carbon, and then oxygen. Okay, cool. Now let's look at each one. So the hydrogen, this 2 belongs to the hydrogen right here, again, to the element to its left. Boom, that gives us 2. Carbon does not, again, does not have a subscript. So because of that, boom, we are going to end up with 1. So again, when it has no subscript, then it's 1. And then oxygen has a subscript of 3, and that's going to give us 3. So then atoms in total is going to be 2 plus 1, which is 3, and then 3 plus 3 is 6. All right, so that is what you need to do for each one of these on this list, okay? So for each one of these ones on this list, you need to go ahead and write that out. So write out the chemical formula first, and then go ahead and write out each element, and then go ahead and add up how many atoms there are. So go ahead and do that for each one. You may need to, and you're going to need to use your periodic table to look up some of these elements. All right, y'all, that is it for today. Peace.